All right. Let me go ahead and get the live share link so you all can join me. All right. I'm going to post the live share link right here in the chat, same place where we have the problem. So give everyone a couple of minutes to click this link, pop into my code editor. While you all are hopping into my code editor, I'm going to finish setting up the code for this problem right here. So, min, pair, sum. I haven't even looked at this. The only thing I look at really until I solve the problem recently is these two numbers right here. How many thumbs up it got and how many thumbs down it got. Because if it has more thumbs down than it has thumbs up, usually the problem is really, really hard to understand. As long as the thumbs up is 5-1, it's usually pretty clear and makes sense, you know. It's really clearly defined. All right. All right. I shared the live share link. Everything is set up and ready to go. So whenever
The link is misbehaving for me for some reason.
is it working for anyone else?
I just got an error.
It's working for me.
Oh, there we go.
Okay, cool. Cool.
Yeah, I don't know what was wrong with it the first time. It opened up, but there was no folder open. I was like, hey, wait a minute.
Oh, weird. Are you opening up in the browser now, Kevin, or in Visual
No,
Studio?
it opens the browser, but then it somewhere along the line, way back when, I clicked, don't show this again. So now it takes me straight into VS Code, but the first time it did it, there was no folder open, and that's unusual.
Gotcha.
Yeah, it looks fine now.
Cool. Cool. Give everyone just a couple of minutes to come in. It looks like Kevin and Virginia are here right now. I'll give everyone else just a minute or two, then we'll get started. Welcome, Fernando. I'm going to be doing on Mondays moving forward, at least every Monday until September. I'm going to be doing all day data structures. It's going to be crazy. It's going to be crazy. But I really want to reach a certain level, and I'm not like I see some progress, but I'm not progressing the way that I want to progress. So I'm like, all right, I'm going hard one day a week. And so I'm going to schedule, or at least I'm going to be just in a channel solving data structures all day, like from 12 to 12, just grinding it out, solving as many as I possibly can. And whoever wants to join is free to join. Not like you guys have to stay the whole time. You have to be crazy to do that.
Yeah, that's really cool.
Yeah, but I think it'll be good. I think, you know, you solve the problems consistently, like you do one a day, you solve them, you start seeing your progress on like the competitions on weekends. You know, you're solving more problems, and you see the improvement when you do at least one a day. So I would recommend at least one a day for anybody. But I'm trying to step up my game. So
So one question, you were doing Leetcode, right?
yeah. Yep.
Yeah, you mean those? Yeah, because I was reading an article today, and they have like other platforms, but I think this is the most famous one, right? The Leetcode.
Yeah, there's tons. I think like Hacker Rank and Code Wars and Omar shared a couple of them too with me.
Something about cake. I think I remember something.
I haven't seen that one. Yeah, they all kind of do the same thing at the end of the day. I think I'm just it's just a habit to go to Leetcode. It's the one that I was introduced to first, and now I'm like, unless one of the other ones do something like really different and it's really beneficial in a unique way, I'll probably just stick with this, you know. It has to be really different and beneficial. All right. So let's go ahead and try to bust this out. So the pair sum of a pair AB is equal to A plus B. The maximum pair sum is the largest pair sum in a list of pairs. Easy enough. For example, if we have pairs 1 and 5, 2 and 3, 4 and 4, the maximum pair sum would be max 1 plus 5, 2 plus 3, 4 plus 4. Okay. Equals max 6, 5, 8 equals 8. Yeah, that makes sense. Given an array nums of even length, so it's always going to be even, of even length n, pair up the elements of nums into n divided by 2 pairs such that each element of nums is in exactly one pair. The maximum pair sum is minimized. Return the minimized maximum pair sum after optimally pairing up the elements. Okay, so we have to take the elements that are inside of the nums array and pair them in a way that minimizes the maximum pair sum. All right, let's check out this first example. So we get an array of 3, 5, 2, 3. The output is going to be 7, so we're going to output an integer. The elements can be paired up into pairs 3, 3, and 5, 2. The maximum pair sum is max 3 plus 3, 5 plus 2, which would evaluate to 6 and 7, and which would be 7. So so we want the minimum. Yeah, because if we combine
on the first
5 and
example,
3,
apparently we have to put the 3 and the 3 together.
yes, because if we put 5 with 3, then that would be 8, and 8 is greater than 7. So we want the lowest maximum we could possibly get. So we have to pair these in a way that it returns the lowest maximum. So n equals nums.length. Cool. N is going to be anywhere from 2 to 100,000, so this could actually be pretty long. N is even, so it's always going to be an even number of elements. And then nums I is also going to be anywhere from 1 to 100,000.
Oh, jeez. They
So,
went out of their way to make the English explanation of this twisted and weird.
yeah. So it seems like we want to take the greatest number and pair it with the lowest number, right?
Well, in the two examples, that holds, but
The way it seems
I
to
guess
me,
you could
just
try that.
intuitively.
So
And it looks like they expect you to match, if it's the same number, put them together in a pair.
So we should sort it.
If we sort it, I'm trying to think of any examples that would break that.
So, what would be like nums here? Like, what kind of data structure? Then to
Say that again? Oh man, that background noise is not good.
oh, what is nums? The numbers.
Nums
And
is
the
an
info?
array. Is an
It's an
array.
array of integers,
Yeah.
Oh, I see. Alright. Interesting.
but there can be a lot of them.
Yeah, I'm thinking, cause yeah. Cause if we have, I'm trying to think of an example of an array that wouldn't work with. Cause if we pair our greatest with our lowest, and then we continue pairing each greatest with the lowest until we get to the middle, that's what you want to do, right? Cause let's just say, for example, we had 4, 4. What if we had a 4, a 4 and a 4 in here?
I think you'd still match the 4, but then you get an 8.
Yes, an 8 instead of 7, but that would still be the lowest, right? Like the lowest possible, because if you matched, yeah. See,
Each element is in exactly one pair, and the maximum pair sum is minimized.
so if there was 4, let's just say, yeah, because 4
Yeah, and
plus
the only way
5,
to satisfy that condition
8,
is your
2.
biggest and lowest numbers together.
Yeah,
Wait, so
yeah,
4 and 3, 4 and 3 is 7, right? 4,
yeah.
3, 4, 7, 5, 2, 7.
Say that again.
Sorry, 4 and 3. If we matched 4 and 3 2 times, we get 7. And
Yeah,
then 5 and 2, we get 7 again. So would it be 7?
4 and 3, 4 and 3, 5 and 2. Yeah, with our algorithm, that would, yeah, you're right, because it'd be
Oh,
5.
wait, but,
It would be 5 and 2, 3 and 4, 3 and 4.
oh, yeah, that
Yeah,
makes sense. If
yeah,
it's sorted, it's still gonna match that way.
yeah. Yeah, unless we're not seeing something, I think that's the
And
way
in
that
this,
we.
in the second example, something similar happens. You get 8, 8, and 8, so you return 8.
Yeah. All right.
Yeah.
All right, let's try it. So sort the nums array.
One use case, if I can add, is something like 3556. From what you said, if you add the highest number, the lowest number, that would be 6 plus 3,
9.
and 5 plus 5 in the middle, 10.
Yeah.
Yeah.
I guess you can decrease it any further.
Yeah.
I mean, if you add 5 plus 3, I guess the other one is 5 plus 6, so that would be 11.
11,
So,
yeah.
okay, yeah, cool.
And then okay. So we can
Once it's sorted, you take the first one and the last one. That's equal to your smallest and biggest.
do we have to push to an array, or will our yeah, I think we would have to. And then we'll
Well,
max that
for
array, right?
yeah, for diagnostic purposes, we want to be able to see the pairs.
Add left pointer to right pointer, we'd have that sum. And then push it onto the array. And then after the loop, we would just return the max, right? Which should be the minimum. The minimized max, hopefully. Yeah, am I missing anything? Sort the numbers. Oh.
That doesn't quite make sense to me.
Yeah. So what array was 0, 7, 7, and 9?
Say that again?
That would work, right? I'm just thinking of weird cases. That's still the minimum, right? 14 would be the minimum.
What numbers?
0, 7, 7, 9.
0779.
Yeah, it's still good, right? 14 is still the smallest.
9 and 14. Yeah, because if you paired 7, then you would get 16
It has
with the
to
other pair.
between it has to be between 1 and n power 5, so the 0 may not be valid 1.
Say that one more time.
If you look at the constraint, the fourth constraint says sum of I need to be between 1 and
100,000.
yeah, so 0 may not be a valid entry at all.
Oh, yeah. But even if it was 1 right here, if you
There's no
paired,
negative numbers, so we should be good, I guess.
yeah. Push the sum to the array, so create the left and right pointer, loop to the nums array for each.
I don't know why we need to loop. You're just going to move your pointers.
We just take the, wait, what if we just take the two end numbers?
That's what
Just
I was thinking.
sum
That's
them
what
in
I was
That's what he's
thinking.
talking about,
sum them in
yeah.
return them. Yeah. Take sum, what? Index 0 and index
Maybe
length minus 1?
increment to left and decrement to right.
Is that always going to be the lowest though?
I don't know.
No, it won't be because if we have 1, 2, 2, 9.
Yeah, you're right. I was getting excited.
That'd be nice. I know that would be easy. That'd be very efficient if it worked. So increment, decrement, pointers, and then so we'll be going while left is less than right, because because once left passes right, then that means that those two in the middle are
Yeah, it's always an even number, so
Yep.
they won't point to the same one.
Yep.
Lucky for us.
All right, cool. Let's try it out. Does someone want to go ahead and type out this code?
I've been thinking about this step, like push the sum to the right. If we are going to select the maximum sum, can we make to this in this step just a comparison with this max?
Yeah,
Like
you're saying just create a variable max and test whether the new pair is greater than the current max pair.
yeah,
Yeah,
instead pushing
that makes
the
sense. Yeah, we could do that if you want. Test current max against max. I don't know. Yeah, so we're not going to need this pairs.
Well, I think it's useful if we want to, we might want to see what's happening.
Well, I guess
just to verify that it's grabbing the right pairs.
Okay, yeah, we could do that, and we could also we'll keep both of these. So we'll test the current max against the max, and we'll push it to pairs array, and then that way, as long as the algorithm works, then we'll cut out the pairs array, and
Yeah,
we'll
just
keep...
for diagnostics.
Yeah. Cool. Awesome. Max value. Yep. So we got a max value too. All right. Everyone pick a line and type.
I did the hard part.
I know. Kevin, I could imagine the beads of sweat coming down your head on that one.
So let's go ahead and make a...
I return the result.
You got it, Omar?
Yeah, I solved it, but in faster way. I'm working on the easy one.
Nice. Cool.
I like left pointer, but whatever. Oh, what's it working about?
Oh no. Oh. We did that twice. I think Fernando was typing this down here while you were doing it. All good. We're actually returning the max value. Perfect. All right. So let sum equals nums left plus nums right. Or we could just do max value equals max value is less than sum, then max value stays the same. As sum. Did I write that wrong? Oh yeah, I did. Oh, if max value is less than sum, then max value sum. I think. All right. And then we could actually we should push this sum to the pairs before we do that check, just so we know we're gonna get it, right? So that'll be a pair right there. Do you want to push the I guess we could push the
I was thinking the actual pairs,
that's what I thought you meant.
just so we can make sure it's doing what we think it's supposed to be doing.
Yep.
It probably will. This is not all that complicated once you figure the English out.
Okay. Cool. Increment,
These are
decrement.
all left and right.
Yes, left and right. Perfect. Then just return the max, right? All right, let's test it out. Does that look all
Yo,
right?
this is so exciting.
Let's see. All right. 7 and 8. Nice. Awesome. And then let's
Yeah, but those are little bitty arrays. Let's see what happens when Leetcode hits it.
I want to see what the pairs array looks like too. Yeah, okay. 2, 5,
Yep,
3, 3.
exactly like it's supposed to. So yeah, you could rim that out, I guess, or tear it out, either way.
Pairs, yeah. Cool. That'll save us a little bit of space.
Yeah, speed it up.
Cool.
So you can probably save a lot of space, truthfully.
Yeah. Come on. Cross your fingers. Woo!
Accept it.
Nice.
Not bad at all.
Yeah, that's really good. Nice.
Ooh, that's slick.
Yeah, really quick. Really efficient. That's great. Good job, everyone. That was awesome. Let's see how the Python team is doing. Then we'll share our easy and our medium solutions. We'll exchange some stuff. I'm gonna pop down there real quick and see how they're doing, and I'll pop right back in. All right.
Oh, okay. So then would I just be like Morse A, and that would give me
What's up?
Exactly.
Got it,
Morse
okay.
A would give you that. Yep.
Okay. Hey, Jimmy.
Hey, how's it going?
Oh, slowly working through this.
Awesome. Which one are you guys doing?
The easy one.
Oh, cool,
Yeah,
cool.
working on the Morse code one. Yeah.
Nice. That was a fun one.
Yeah, he's definitely he's coming along and he's pushing through it. It is pretty cool.
Nice, nice. We just finished the medium one up here, so whenever you guys are ready, just pop back up and we'll exchange some solutions.
Cool.
Heck yeah, man.
Cool.
Alrighty, see you soon.
Thousands of numbers, that pairs array would have gotten big and taken up a lot of memory.
All right. What did someone say? Why did we get rid of the pairs array?
Yeah, basically. Yeah.
Ah, okay. Yeah.
I solve it in a similar way but different syntax. Different. Let's share my screen.
JavaScript, Omar?
Yeah, JavaScript, but different syntax.
Nice, nice. Yeah, let's check it out.
So I first sort the string, set maximum to minus infinity, and then loop from 0 to length divided by 2, and compare max with the none of the I item from the left with the I item from the right, and then return max.
Hold on, you're only looping until nums.length divided by 2?
It's the same algorithm, really.
Yeah, similar way of
Oh,
solving.
yeah.
A little worse on the memory.
So I store only one array in the memory, like your algorithm. So which worse in terms of memory?
Yeah, that makes sense. And then math.
Yeah, and running that max on an array is expensive.
Oh, yeah, because you're running the max method.
But it's only comparing two numbers.
Yeah, true.
So if I compare two, so you also compare two number in your solution.
Exactly. Yeah.
Yeah, but we didn't use that math.max.
I wonder what the overhead for a math.max is. Like, there's got to be edge cases built in within that method too, where if there's only two numbers, it does things just as fast, though, right?
Yeah, it's probably optimized for a big set. So giving it just two numbers is
overkill.
Overkill, yeah.
So so it's better in this case to just compare using if statement.
I'm checking right now. I think really to find out this information, I have to go to the specs, right? Math.max.
Well, somebody on Stack Overflow has probably asked that question.
True.
So when I replace the math.max with if statement, my average number on Leetcode decreased. Of course, it is not a measurement because Leetcode change varied due to a lot of factors, but that's why what I notice. Like the overall efficiency decrease.
Yeah, but we didn't even use a for loop. We were just adding to one number and subtracting from another.
Yeah, there is a for loop inside of the math.max.
Yeah,
method.
that's not efficient for just two numbers.
Actually, there's two for loops inside of it. They're not nested inside of each other, but you're calling a for loop when you don't have to call a for loop. So I think you're doing things you just don't have to do. So I think that might be with something this small, though, even
Still a valid
100,000.
solution though.
Definitely.
Still works.
Definitely. It's smaller and cleaner, I think.
Oh yeah, it looks better. Give it
Yeah.
that.
Yeah, definitely. The code is much more succinct, you know? It's tightly packed. I like that. Whereas this, yeah, we just wrote an if statement, basically. Nice. John is working through the first solution with really bad chess. I don't know his name yet, but I'm going to go ahead and share my easy solution for the first problem. Just so we could keep it pushing here. What was the first problem called?
The Morse code one, it was cool.
Oops. Unique Morse code. Oh yeah, that one was fun. So this was actually a pretty efficient solution too. I like this one. So basically what I did here was, can everyone see my screen?
No.
No.
Hold on. Anytime you change into another channel, it does that.
Yes, it does.
Aha. Here we go. All right. So basically what I did was I copy and pasted the Morse, so I already had access to that, which took up a little bit of space, but it sped things up a lot. I already had access to all of it. So first thing I do is check if words.length equals 1, because if words.length equals 1, that means there's only going to be one transformation or whatever you want to call it. So I just return 1 there. Then I create a set to keep track of the existing transformations, since I know that you're only going to need to keep track of unique ones. And then I loop through the words array. So I'm looping through each one of these one by one. And I'm creating a new variable called string to Morse, because I'm converting this string right here into Morse code. Then loop through characters of word. So I'm actually looping through just each character one by one. And for each character, I am taking that word character code at I. So I'm finding out the ASCII value of the character, which A is 97, B is 98, C is 99. So if
Yeah,
you
if they're all
subtract,
lowercase.
exactly. So if you subtract 97 from it, like if I do word at character code I, and I is I is targeting this A right here, it's going to return 97. And if I subtract 97 from 97, I'm going to get 0. And then I just do string to Morse. I concatenate Morse with 0, which would be this. So I'm just concatenating. But if, let's just say, for example, it's G, so character code at, so it'd be 97, 98, 99, A, B, C, D, E, F, G. So it'd be 7 after 97. So it'd be 90, 97, 98, 99, 100, 101, 102, 103. So G would return 103 minus 97 would give me back 6 because it's 0 index. So it'd be 0, 1, 2, 3, 4, 5, 6. And it would just concatenate that onto the string to Morse variable. And then I just checked if the transformation set has that Morse code, then I continued and I didn't do anything. But if it didn't have it, then I would add it to it. And then I just returned transformation set that size because I knew that any Morse code string that was stored in the transformation set was unique. That was a fun one. Did anyone else solve it differently?
So, but I have a question about your code. Why you add line?
Why what?
Why you add line 24?
24.
So,
If transformation set has string to Morse continued. I was actually
So
wondering about that because I think if you try to add a value that already exists on a set, then it just doesn't add it, right? But you don't get an
so
error.
I am worried like the add method behind the scene check if the set has or not. So it's like uh I think it will check it itself.
Yeah, I was wondering that. I just didn't. But do you get an error or let me see.
No, not no error. I don't think so.
Yeah, you're right. I don't even need to do that check.
Uh,
You're right.
so another thing, uh, why you don't on for loop line 17? You can like why you don't simply loop let char of word. So you could let car of like character of word. You could loop through the character of string
And then I could just put
using
char right here
yeah
to get the ASCII value.
yeah exactly.
This is to
So
make it more clear, you're saying?
yeah.
Okay. Let's
So
you're saying just do this right here. Let char of word.
word yeah. And for your variable at 19, you could set it as let ASCII equal word dot char code at I dot at char. Or you could at line 17 let I of word. Okay.
Yeah, let's try this out.
No, they,
Cannot
no,
access
this
char.
because you said
Oh
let char.
yeah. We could just
So
do
you
ch. It's off.
Yeah, I'm not sure that the let ch of word gives it in the right order.
So usually if I want to loop through the string, it works with me, like looping using the off syntax.
I wonder if because it's giving me a transformation set of 3, which
So
means
maybe it loops through. Okay, it needs some. Maybe it's a loop through the character and convert it right away to its code. So because you said because you when you said word dot char code at char, you pass like if the word is ABC, you don't pass the index. So you need let ch inward.
to return the actual index, you're saying. Yeah, you're right. Yep. Let's test it out. Here. All right. I'm in the truth. Woo! Actually, this is way worse, but it's all good.
Wait, we can write all our for loops like that?
Yeah, you can. Nice.
Nice.
Yeah, this is much more clear for sure.
Yeah, it's got that evil nested loop.
I think these days most people do write their for loops like this, right? I don't know why. I learned coding with C language from CS50, the David Milan's course, and so like kind of stuck in that, just writing it old school. But yeah, this is definitely more readable for sure. Like you could kind of, even without comments, you could kind of tell what this code is doing, which is nice.
Yeah. So and also this help you to start learn Python because Python like use similar syntax.
Yeah, true.
So there is a few optimization for this code. Like if we store the Morse code as a map, that map like the character with each with its Morse, like Morse equals your bracket A to dot B to 3 dots and so on. So if we make a map, we don't have to
Find the character
calculate.
code. Yeah.
Yeah, so we just simply just passing the character and it will return the Morse code of it.
Yes.
So this somehow optimized.
That will be good for that'll make it faster, but it'll take up more space, right? Just a little bit, because maps take up more space than arrays.
Yeah, it will take more space.
Can I see your code? Can I see your solution for this problem, Omar?
I haven't tried my solution, but I was coding it the same way you code it.
Gotcha.
The same way.
Yeah, this was a fun one, right?
Yeah.
Honestly, I feel like the medium problem today was easier than the hard problem. I mean, the easy problem.
Yeah, totally.
So, quick question. I know normally when we try to look at the time complexity, we understand how many loops are there, how efficient it is O of n or O of log n, stuff like that. But for memory, how do we try to measure things?
I was just thinking about that today. I was like, because I'd never really think too much about memory. I was like, so I started digging through some big O notation resources to really understand how the memory is calculated. But intuitively, I was thinking if I set like an object outside of a for loop, then that would be O of one operation, right? But if I create an array every time I loop through another array, I don't know. That's a really good question. I want to figure that out. I was giving it some thought today, though. Does anyone know that answer?
I guess you need to know what is the largest data structure during executing your code. For example, if you need to find maximum value inside an array, and you only at each iteration compare two numbers, so you need only to store in your memory one variable, one number, so that would give us time complexity of O1.
Yeah.
But if you need to store, if your code need to store a whole array during execution, so that will be like O of n. So it depends, like if you, for example, if your code need to create a map, and this map will have, you will expect it will have the length of n, so that will be O of n the space complexity.
Yeah. So if I'm inputting an array into a function and I'm taking that array, and for every element inside of that array, I'm storing it inside of a map in a for loop, then it's a O of n memory complexity.
Yeah, exactly.
But if I just create what if I create an array like this though, here, like this Morse code, where it's just hard coded, but there's 26 characters, and it's not dependent on, it's constant, right? Like this is,
That's constant, correct, correct.
yeah.
And the words have a constraint, so you know that 26 constant is nothing compared to the what the words could be up to in this
Yeah.
case,
Yeah,
or
exactly.
and letters, because it's, you know, That essentially you have to run through every single letter. So
Yeah, for this code, if the words is less than m, if words dot length less than m, the space complexity is O of m.
M?
Because if the word length is less than m, the space complexity is O of m, because inside the variable string to Morse we store, it's depend on the length of the word.
Yeah.
Okay, so I got a question. So that's O of n plus m, or is that just n? Because technically the length of our words is every letter, which is n, right?
So this is the worst case for the word length. So it's depend like if you pass a word length with 20 and you pass a word length of 40, you expect your algorithm for 40 to take double the space complexity of 20.
See,
but if the strings, like, let's just say for the first example we have four words, right? And each one of the words is 3 characters. Each word, or the number of words that exists, 4 is n, right? That's what we're iterating over on the first for loop. That makes the solution O of n, right? And if we're iterating through the words again, it would be O of n squared, n times n, basically. But
no, that's the m.
yeah, this is the m, because this isn't the words. This is the actual number of characters. So it would be O of n to the m
plus m, because each one varies. Each one can vary. It's not all gonna be 3.
No, I think they said that it's gonna be all 3, right?
No, the words length can go up to 12 characters. So I guess because the constraint to the max 12. So 12 times the max of words, which was 100. So the max would be 100 times 12, which, like he's saying, is n. 100 could be the worst, because that's what we're talking about, worst case scenario. 100 times 12. So n times m. Because each word could be up to 12 characters, and that could be 100 long. Worst case scenario with their constraint.
Okay, for some
yep.
reason.
So not plus, times. My bad.
Okay.
Times.
Yeah.
Yep.
I thought for some reason that they said that if one is 3 characters, then all of them are going to be 3 characters. Probably just figured that by the example here. Cool. Did anyone else solve this medium one here?
Yeah, the medium was fun.
Right, wasn't it? Did your solution look like this, or did you do something else?
I thought the Morse was the easy one.
Yeah, it was.
I thought you said medium. My bad. Yeah. Put it in the chat.
Cool. The lobby chat or the chat?
Oh, the chat. The lobby chat. I'm sorry. Lobby chat. Yeah. Get myself mixed up sometimes. The little chat on the lobby button. Yep.
Cool.
That bottom one. Yep. That bottom one
Sure.
is the easy one.
It's
it's small.
Yeah, it's hard to see. Let me open original. That's a little easier to see. There we go.
Okay. There you
go. Okay, so you did what Omar said. Yep.
Yeah, that top one's the hash map little thing, and then the second one's similar, just uses a counter, so I don't have to use the length function at the end, like the middle one.
Yep.
And then The bottom one just uses a set, but still uses the scene or
If
the
we
link.
if we ignore the line 4, the rest of the code look like in JavaScript.
Really?
Yeah. So for the medium one, you create 2 pointers. So I create it without, I solve it without pointers.
You talking about the medium one?
Yeah, for his solution. So if you scroll up in the chart, in the lobby chart,
Oh yeah.
yeah, so you create 2 pointers. So
He's talking about the top one, Jimmy.
This one here?
yeah.
Yeah, or the middle, same thing. But I was like, holy crap, Leetcode's tripping out. They gave me a good, yeah, they were tripping.
So you can sort the array and then sum the like I element from the left and I element from the right
Right.
inside a for loop. Okay, let me
The
share
old
my.
pincher's movement.
Yep.
Yeah, that's what this is. Yeah, it's just almost like a, oh yeah, you said pincher. Reduces in, comes in, yeah. Similar to like the sliding window, but not. I don't know. Just
No, it's not like the sliding window. It's totally different.
Fight! Fight!
oh, I'm not going to argue with him by any means.
You shared it, Omar?
Okay, I'm sharing it.
We did the same exact thing you did, John, too.
Right on.
Yeah, the only difference is we didn't create a halfway variable. We just did while left is less than right.
Right.
My
That was
screen
just part
won't.
of experimenting with trying to not use the length of nums.
Yeah.
Right.
True.
And it didn't affect it, so I just left it. But yeah.
No, your screen's not working, Omar.
I will share the solution in the lobby chat.
All right.
So
Cool.
yeah.
Yep. Yeah, this one felt like an easy today too. The medium one felt like an easy one.
Yeah, whoever drops those into the buckets has bad days every now and then, I think.
Definitely. All right, nice, yeah. You just return the max. If max less than nums I plus nums dot length minus 1 minus I